Thinking Aloud. Conversations on the leading edge of knowledge and discovery with psychologist Jeffrey Mishlove.
Hello and welcome. I'm Jeffrey Mishlove. Today we will be exploring the cosmic hologram, the role of holographic information in the universe. With me is cosmologist Jude Currivan, British cosmologist and archaeologist, author of several books. The most recent one is The Cosmic Hologram. She is also the co-author with Irvin Laszlo of Cosmos. Welcome, Jude.
Thank you, Jeff. It's wonderful to be here.
It's a pleasure to be with you as well. And you're pioneering a very interesting model of reality, which states that at the very core of the whole cosmos, of the physical universe itself, is information embedded at a deep level, and information that interacts with each other throughout the whole universe.
Absolutely. I mean, the premise is that all we call reality is information, and information, as you mentioned, holographically realized.
Well, many of our viewers are going to assume that information is somehow very different from matter and energy, and yet I guess according to the Shannon Weaver information theory, they're really practically identical.
Well, they are, essentially, that information expresses itself as energy and matter, and in a complementary way. What the evidence is showing is that it also expresses itself as space-time. So we literally are moving towards an understanding that our universe, all that we call physical reality, is emergent from deeper levels of non-physical realities, which is what the ancients and, essentially spiritual traditions have always told us. But now leading edge science across many fields is pointing in the same direction.
And I gather from your work that, let's say, at the very moment of the Big Bang, the whole universe was already encoded.
Essentially, but not totally. It was that rather like a newborn baby. It was as simple as it could be, but no simpler. So what was encoded from that first moment that I call the big breath rather than the big bang, because it was incredibly fine-tuned. The forces of our universe are incredibly fine-tuned to allow it to exist and evolve as a unified entity. So at that very first moment of that big breath, its experience, as it were, as a baby was at its beginning. But it had all the energy matter, it had all the physical forces there ready to go. But ever since, it's been evolving. So it was able to exist from that first moment. But since then, as time has flowed, as space has expanded, it's embodied ever more complexity. In other words, it's evolved from that initial simplicity to ever greater complexity.
Now, and the expansion of space itself has always puzzled me. Could you elaborate on that? How is it that space expands?
Well, first and foremost, I would say that, cosmologists are more and more coming to a perception that our universe is finite. It began 13.8 billion years ago, and it's finite in that space is finite, time is finite, and it will come to a completion. That's not 100% proven yet, but it's certainly the direction of travel of cosmological discoveries. So in a way, we can consider our universe as a finite entity within the infinity of the cosmos.
But in terms of the expansion, here's the puzzle to me. As you say, the universe is 13.8 billion years old. The speed of light is a finite speed as well. So one would expect that the universe, the diameter of the universe, or the radius, let's say the radius of the universe, shouldn't be more than 13.8 billion light years. But it is larger.
It is, and that's to do with the way that the initial expansion happened. But going back to your question, which I think is a key one, why does space expand? Think of our universe as a thought bubble, okay, or a thought balloon. So it began at its tiniest, and it's been expanding, as you say, ever since. So rather like an out-breath, space expands. And when we add in the other leading edge discoveries, which is that the boundary of space is rather more like a holographic boundary, and all we call physical reality is rather like a projection, a holographic projection from that boundary. Space has to expand to allow ever more information, experience, evolution, complexity to be expressed within what we call space-time.
It sounds as if you're saying that the expansion of space is related to the expansion of consciousness in the universe.
Indeed, exactly that. Because when we've looked at black holes, we've realized that the information of that star that's then pulled in by its gravitational attraction to form a black hole, when that gravity is so strong that even light can't escape, a black hole is surrounded by what's called an event horizon, which is why it looks black. But around it, you have this event horizon. And what we understand is that all that information of that initial star doesn't get lost to our universe. It actually is held on that event horizon. But instead of being proportional, because black holes are spherical, instead of being proportional to the volume of that black hole, that information is proportional to the surface area of that event horizon. And at the tiniest scale of our universe, called the Planck scale, one digitized bit of information is held on every Planck scale area. So it's as though that event horizon of a black hole is covered in little triangles, each of which holds a piece of information about the star. So what cosmologists have done is expand that to the scale of our entire universe and said that is the holographic boundary of what we call space-time. So space has to expand, so ever more bits of information, consciousness, can be expressed in our universe.
In other words, for you, information isn't the way we might think of it in a computer as simply a bit. Information has a vitality, a consciousness to it.
It doesn't have a consciousness to it. It is consciousness. Consciousness expresses itself through pattern, dynamic, relational information, which in the book I show as in hyphen formation, because this is meaningful, patterned, as I say, dynamic, relational, which informs the nature of physical reality. But it is still the same as the digitized information on which all our
there are philosophers such as John Searle, a philosopher of mind, who maintains that you can have an interactive informational system without conscious awareness at all.
Indeed you can, but the thing is that consciousness is very clever, and consciousness manifests itself as simply as possible. So it so happens that the laws of physics which enable our universe to exist and evolve are like algorithms, the same algorithms that we write the instructions so our computers operate. The laws of physics are the simplest of algorithms instructing our universe how to exist and evolve. And as a finite universe, the simplest way of consciousness expressing itself is through digitized information. And that's the way it does. Just as we can, the way we're having our interview, our voices are being translated into the ones and zeros of digitized information, thrown through our computers, recorded, and then retranslated into the sound of our voices. Well, our whole universe is the masterclass for which all of this are kids' toys.
Now, you describe in your book an experience I believe you had in childhood. You refer to it as Indra's net.
Yes.
Let's talk about that, because I think it'll give our viewers a more visceral sense
Absolutely. Well, Indra's net is an amazingly beautiful vision of reality that comes to us from ancient India, from the Vedic scholars of ancient India, so thousands upon thousands of years ago. And they describe reality in this way. They say, think of a multitude of gems, and each gem, each jewel, has a myriad of facets, and each facet of each jewel reflects to each of the other numerous infinity of jewels, and is joined to each by golden threads of light. So the universe observes itself at every level. The universe is interconnected at the most fundamental level and reflects itself and knows itself and emerges and evolves. And that is described as Indra's net. Now, in current language, this is the cosmic hologram. In scientific terminology, this is what scientists are discovering is indeed the nature of reality.
And if I recall correctly, when you were a child, you experienced this in a state of altered or higher consciousness.
Well, very much so. When I was 4 years old, I had my first experience of what people would perhaps call supernormal phenomena, telepathy, precognition, out-of-body experiences, and all of it. And so, the first experience of that was when a discarnate light came into my bedroom when I was 4 years old. But that started the journey. So all my life, I've experienced this physical reality of just one of many realities, interwoven and ultimately unified, playing out consciousness on many, many different levels and levels of self-awareness and experience.
So I guess it would be fair to say then that it was this mystical experience from early childhood that motivated you to enter into science.
It was, because I was curious. I think when people ask me, you describe yourself as a cosmologist, what does that mean? I answer that, I'm curious about the nature of reality, the whole of reality, not just this physical realm, but what of all of the mystical experiences that people have had throughout history? What's the nature of love? What is the nature of thought and understanding and experience? So I'm curious about reality itself and not just what we call the physical realm. So that indeed, as part of that journey, science is a wonderful language and a wonderful methodology to offer us a perspective of consensual reality, and at its best, to follow where the evidence leads in that, search and that quest for discovery.
And the thrust of your scientific work then has been to really develop at a formal mathematical level even this notion of information as the core of the cosmos as we understand it.
Absolutely. And Marcel Proust once said that the journey of discovery is not discovering new lands, but seeing with new eyes. So I haven't needed to create or describe any other mathematical formalism for this. The mathematics is there, the laws of physics are there. It's just restating them as algorithms of information. And it's understanding that what we can do is to take the laws of thermodynamics and restate them as laws of infodynamics.
Which is what you have done.
Which is what I've done.
Laws of information. For example, you talk about the conservation of information being related to the conservation of matter and energy.
Absolutely. That the first law of thermodynamics is that in a closed system, energy is always conserved. Now, if we expand that to what cosmologically is being discovered, and there's certainly more and more evidence for that, if we consider our universe as a closed system, then we can take that as universal. So our universe conserves energy, but we know energy and matter are equivalent. So our universe conserves energy, matter, and we now know both from the theoretical view and experiment that information is as real as and more fundamental than energy, matter. So we can say that when it's expressed as energy matter, it's universally conserved.
Well, if information is encoded in energy matter, and energy matter is conserved, so that the total amount of energy matter in the universe remains constant,
yes.
how is it that the amount of information and consciousness keeps expanding?
Because you need two laws of thermodynamics. You need two laws of infodynamics. So information expressed as energy matter is the first law and universally conserved. The second law is crucial. The second law of thermodynamics says the entropy of a system, closed system, always increases. Now, when Ludwig Boltzmann came up with that first law of thermodynamics, he was talking about the microstates of a gas. When we now restate that as a second law of infodynamics, what we're saying is that the informational entropy of our universe must always increase. So he said the microstates of the entropy, the microstates of a gas must always increase through time.
That's the law of entropy.
That's the law of entropy.
Boltzmann's law.
Boltzmann's law.
I know it's inscribed on his tombstone.
Yes, it is.
Yeah.
Yes, it is, because it's a very simple equation.
And our viewers might be interested in checking out an earlier interview with physicist Edwin May, who goes into this and shows that Boltzmann's law is related both to time and to gravity. And I know you echo that in your work.
Very much. And so basically by restating that second law of thermodynamics, the entropy of a gas must always increase through time. We're talking about the entropy of our universe must always increase through time. But by restating entropy, instead of microstates of a gas, as the informational content of a system. So our universe began with the informational content of it as its minimum, which has been increasing through time ever since. And that's why when we consider entropy, we need to re-understand it as simplicity to complexity. There was less informational entropy in our universe yesterday than there is today, than there will be tomorrow. That's how our universe evolves.
Now, I have to say this. Logically speaking, you've just hit on what I find is the most puzzling aspect of your work, because, to my knowledge, entropy is not the same as complexity. They're very different. Entropy means disorder.
No. That's where the mistake has been for a long time. We've considered entropy as order to disorder. Okay? It actually isn't that. It's the increase in the number of microstates of a system. So, for example, if I had a glass of water on this table and it was just sitting there, it would have a number of microstates and it would be ordered, indeed, because the water's not going anywhere. Fine. I spill that glass and the water goes everywhere, maybe the glass breaks. That is disorder in one understanding of it. But actually, the number of microstates of that system is now greater than it was when it was sitting on the table, because the water's connecting with the carpet, it's splashing up your trousers, it's splashing me. So the level of microstates of that system are greater than they were when the glass was there.
So you're equating the increased number of microstates with the increase in complexity.
I'm going beyond that to say that instead of microstates, let's consider the informational content of that system. So the informational content, which is a sort of an informational way of describing the microstates, is less when the glass is on the table than it is when it's scattered. Now, if we expand that to our whole universe, we're going from simplicity or lower number of microstates or a lower informational content to a greater informational content. So as space expands, in every moment, as time flows, more and more informational content can be expressed within space-time, and that's the basis of the way our universe evolves.
Now, to me, this is a revolutionary idea, and I have to say, I have talked to physicists such as Marie Gell-Mann, the Nobel laureate who wrote the Jaguar and the Quark, and discoverer of the quark.
Wonderful physicist.
Writes a lot about complexity and entropy. To my knowledge, your understanding is different than his.
It's further along than his, because when Murray was writing, the understanding of information was really at its beginning. I mean, Claude Shannon was the first to come along and show that the same level of informational, not so much, he didn't fully understand it as informational content. That's something that the informational scientists have moved on and to. So now there is much more of an understanding that that equation of entropy actually refers to the informational content of a system. But we now have experimental evidence of information being more fundamental. We also have the theoretical framework. So when Murray was writing, it was still at the very beginning of this. For example, John Archibald Wheeler, who coined the term black holes, as I'm sure you know, said it from bit. In other words, it, everything we call reality, from bit, digitized information. He would now say it is bit.
I see. So what we're getting at still sound very revolutionary
It is
to
revolutionary.
me. And what you're saying is that your view isn't unique. It represents a scientific consensus.
A developing consensus. And it's a developing consensus that our technologies have really opened the door for us to understand, because the informational signature of the cosmic hologram is not just being understood by physicists and informational theorists. It's actually been discovered by many, many different fields of study across all scales of existence, from the most minute, which is the Planck scale, the pixelation scale of space-time, through to our everyday lives. So we're finding this informational signature of relational, dynamic interactions and flows and processes throughout all scales and across numerous fields of study.
I mean, most people normally think of entropy as that's what happens to us as we get old. Our body decays and we die.
Except that when you understand that it's information expressed, when we die, we have more information because we've got our whole lifetime of information. When we die, our physical body then reconnects with the earth, with Gaia, but our consciousness continues. And that's another interview entirely.
It is, but that's the implication of your work.
It is, and it is the implication of my work, that mind is matter, that information is reality, and that consciousness isn't something we have, it's what we and the whole world are. And we really need to understand that entropy is more appropriately understood as the informational content that always increases through time.
I've heard some people say, for example, nature doesn't waste anything.
Nothing.
And therefore, it's inconceivable that a human being who spends a lifetime developing a refined state of consciousness, that consciousness doesn't just decay the way the body would.
Absolutely, and even in the bodily decay, if you consider that every Planck scale moment, our universe as an entirety is experiencing, embodying more and more information. Even our ashes, even our body, you know, the interconnection with the soil, with the earth, there's still everything is information. So that information is still increasing, always increasing. We need to expand our awareness to the scale of our whole universe to fully understand that by existing and evolving as a unified entity, its informational content, which is its entirety, is always increasing. Its entropy, its informational entropy, is always increasing. That is the life cycle of a universe. You begin at the 13.8 billion years ago, the highest temperature. As space expands, temperature drops. It's a thermodynamic process to almost absolute zero. But this way, its simplicity, its informational content begins at its minimum and grows to its maximum. It's the most beautiful, exquisite, simple process when you reframe it from thermodynamics to infodynamics. And by the way, you can also look at reconciling quantum relativity theories, because they are different complementary expressions.
You're looking
of
at these laws of information that you've described earlier as being the laws that bind together
yes.
relativity and quantum theory.
Absolutely, yes.
And in addition, if I understand your work correctly, you address the problem, it's one of the big problems in cosmology of dark matter and dark energy.
I sort of fudge it. I sort of fudge it. What I say is that obviously dark matter and dark energy are vital components of how our universe exists and evolves. And, dark matter, I was speaking with Joel Primark the other day, who's one of the key sort of founder discoverers of our current understanding of dark matter. And it may well be that that's just weakly interacting massive particles. I think standard physics or the next level of physics will get to dark matter and dark energy as a tension in space-time, as a cosmological constant. What I'm far more interested in is the nature of the universe as a whole, and realizing that we can't still perceive it in terms of energy, matter and space-time, that those are emergent phenomena from a much deeper perspective of a unified universe that is ultimately conscious and is innately informed.
Now, like my old friend Michael Talbot, you draw upon the holographic nature of reality. And as I understand a hologram, every piece of a hologram is a reflection of the whole.
Essentially, yes, that pixelation. You can have what Ken Wilber and others talk about holokeys, so holons. So you can have sort of greater complexity. But essentially, a hologram is a reflective, fully interrelated entity where the whole and the pixelations reflect each other.
Well, and I suppose I have to think when I listen to you that you are in effect speaking to me as a spokesperson for the universe. It's as if you are a representative of that wholeness.
Well, that's very kind, and I do feel that in a way, because I feel that it's important for us as humanity now, because we've sort of been told by mainstream science that things are separate and essentially meaningless, and that consciousness is something that accidentally emerges through evolution. This turns all of that on its head and shows that all we call reality is consciousness expressing itself in these ways, and that our universe does exist and evolve as a unified entity. A thought form, if you like, a finite thought form in the infinite mind of the cosmos.
Jude Currivan, what a wonderful discussion. Thank you so much for being with me.
Thank you, Jeff. It's been absolutely delightful.
And thank you for being with us.